Welcome to our channel. Today we will discuss Chapter 2, question number 9 from the PSPM past year paper. Projectile motion is the path of an object thrown or projected into the air. In this case, we're looking at a stone thrown horizontally from the top of a 70-meter high building with an initial horizontal velocity of 40 meters per second. If we ignore air resistance, the stone will follow a parabolic path. This curved path is a result of two independent motions happening simultaneously: constant horizontal motion and accelerated vertical motion due to gravity. The stone's velocity can be broken down into two components: horizontal velocity Vx and vertical velocity V. The horizontal velocity remains constant throughout the flight, while the vertical velocity starts at zero and increases downwards due to the pull of gravity. To determine the overall velocity of the stone at any given point, we need to consider the combined effect of both components. This combined velocity is called the resultant velocity. We can calculate the resultant velocity at a specific height, like 15 meters above the ground, by determining the vertical velocity at that point and then combining it with the constant horizontal velocity using the Pythagorean theorem. It's important to remember that this analysis is based on the assumption of no air resistance, which simplifies the calculations but might not accurately represent real-world conditions. And question II wants us to find the resultant velocity of the stone from 15 m from the ground. We can find using Vi2 equals to Ui2 2a psi. Here we should note that the displacement is negative because the reference point is above, so we get minus 70 minus 15 to get 70 15. At last, we get Vi, and the Vx component is the same as Ux, which is 40 ms. Lastly, we use the Pythagorean theorem to get the resultant velocity of the stone at 15 m from the ground. At this question, it doesn't want us to find the direction or angle of the resultant velocity, but for save, just include the calculation and drawing of the resultant velocity's angle. So for part 3 of this question, the question wants us to draw an acceleration time graph. The initial vertical velocity is 0 meters per second, and after that, it moves downwards with an acceleration of 9.81 meters per second square. Now we have acceleration, which is minus 9.81, and to find the time, we can just use SU12 at 2 by substituting S70U0 and A is minus 9.81, we can find that the time is 3.78 seconds, and you can draw it now. Let's move on to the next question. Calculate the time of flight. For this, we actually did the part in the graph question, so it's the same. We will apply SU12 at square S given is minus 70, U is 0 meter per second, and A is gravity acceleration of dash 9.81 meter per second square. And you will find that the time is 3.78 seconds. For the last question, you need to calculate the range, which is the distance from the reference point to the point when stone hits the ground. You can use the formula SXUTU and sub the value of velocity of component X and time, and you can get the answer now. Thank you for your patience to watch this video. Please like and subscribe. See you next time.